Alrighty, so topic 5 just continues what we already know about solving systems. Really and truly, you could try all of topic 5 without me taking you through anything, but there are some things that are a little bit different or weird, so I wanted to make sure that I had a way to explain them to you. So again, if at any point you want to pause and try the problem first, go for it. You can pause it right now if you want to before I do number 1, or in between each problem, doesn't matter to me. So on number 1, it says find the value of x given the system y equals 3 halves x and y equals 9 halves x minus 1. When you first glance at this, obviously there's a graph, but also they're both solved for y equals mx plus b. So it looks like we need to graph, right? So the first equation is y equals 3 halves x. That means it has a y-intercept at 0, and then I'm going to go up 3 over 2. Up 3 over 2. Go ahead and graph this. Okay, and graph the other one. 9 halves x minus 1. So here's minus 1. I'm going to go up 9 over 2. And then down, oh, I can't go down 9, but I'll just pretend I'll try over 2. Okay, so now when I connect these, it's hard to tell what that point is, right? So it actually appears as though graphing may not have been the best bet here. Now, we had no clue that that was going to happen until we did it, but I still don't know what the exact point is. So what I'm going to do instead is I'm actually going to choose one of my other options for solving and try that instead. So looking at what I have, I can do either elimination or substitution, right? Elimination requires that they be in standard form, and I add them together. Well, these are not in standard form, right? This isn't really the best way of doing it, okay? So I'm not going to do elimination. Substitution just requires that I have a variable by itself. Well, I have y by itself, right? Y is equal to 3 halves x. So I can actually plug that in to my other y. So I've got 3 halves x equals 9 halves x minus 1. If they're both equal to y, this is y and this is y, then those should be the same thing, right? So now, to solve this, I'm actually going to start by multiplying the whole thing by 2, just so I get rid of those fractions. So I've got 3x equals 9x minus 2. You don't have to do it that way. You could solve this without it, but I just thought that might help me. So now, I want to get all the variables on one side, so I'm going to subtract 9x from both sides. So negative 6x equals negative 2. Divide by negative 6. X equals 1/3, okay? That's part of why we had a hard time seeing what this is, because the x value is 1/3, right? Okay, so now to get y, I just have to plug that x back into my one of my original equations. So I'm going to plug it back in to probably this first one. So y equals 3 halves times that third, okay? So y equals 3 over 6, which is a half. So that means my coordinate ended up being 1/3, 1/2. No wonder it was kind of hard for us to see. Alrighty. So here's another one. Again, feel free to pause and work it out yourself. Given the system, blah, those equations, find the value of x minus y. Okay, well, I'm going to look and see what method I want to use. It's already in standard form. Everything's stacked on top of each other. I'm thinking this is pretty good for elimination. So I'm going to add them together. I can already tell that the y's are going to cancel, so I don't have to do anything. So I've got negative 11x equals 11. Divide by negative 11, so x equals negative 1. So there's part of my answer. Now I have to go get y, so I'm going to plug it back into one of these. I'm going to do the bottom one, just for kicks. Negative 3x. I'm going to plug in the, oh, no. Sorry, thought I had y. I'm going to do negative 3 times negative 1 plus y equals negative 5, because I'm plugging in for x. So I've got 3 plus y equals negative 5. So y equals negative 8. Okay, so here's my two values. However, if I go back and read my question, it says find the value of x minus y. So really, I need to do x, which is negative 1, minus y, which was negative 8. Well, that means negative 1 plus 8, so my final answer is 7. That is my real answer here. I had to get x and y to get that, but they really were wanting me to figure out what x minus y is. Okay. Number 3, what we start at this point, the whole rest of the notes page here, is word problems. And we've worked with word problems as far as writing the equations. We just haven't solved them, because when we wrote them, we didn't really know how to solve yet. So Michael bought some tigerfish at $3 each and some goldfish at $4 each for his new aquarium. If Michael bought a total of 12 fish and spent a total of $40, how many goldfish did he buy? Remember, I talked to y'all about underlining a question because that tells you what your variables are. So X and Y, one of them has to do with how many goldfish. So I'm going to say X is the number of goldfish. Not the price, because I already know the price, but X will be the number of goldfish. So look back at the problem. The other thing he bought was tigerfish. So number of tigerfish. Okay, so now I just need to make my equations. He bought tigerfish at $3 each. Well, that's the Y, so 3Y, plus he bought goldfish for 4 each, so 4X. All of that together, I'm talking about prices here. This is a price, this is a price, so that altogether is $40. That's another money term there. Then it says he bought a total of 12 fish. Well, all of the goldfish plus all of the tigerfish is 12 fish. Okay, so I've got my two equations here. Now, we would be done had we had this lesson a few days ago or a few weeks ago, but now we know how to solve, right? So at this point, you have to pick the method that makes the most sense. Well, you could do elimination. I would need to move some things around so that I have everything stacked on top of each other. Or you could do substitution, but I don't have anything by itself. So really, it's a toss-up. It doesn't matter. I'm going to do substitution because I can see that I just have to move this Y over, and now X is by itself. Okay, so I'm actually going to cross through this because I don't need it anymore. And I'm going to focus on X equals 12 minus Y. If I know that X is 12 minus Y, I should be able to plug it in for X, right? So I'm going to rework this top equation. 3Y plus 4 times X should equal 40. But instead of X, I'm going to put in that 12 minus Y. Okay, so now I just work it out. 3Y plus 48 minus 4Y equals 40. That gives me negative Y plus 48 equals 40. Subtract 48. Can't have a negative, so really Y equals positive 8. Okay, that's one of my answers. But they're wanting to know how many goldfish. Well, if I reread the problem, it says he bought 12 fish total. So if 8 were tigerfish, 4 have to be goldfish. And that is my final answer. Okay, so a lot of steps there. You had to find your variables, you had to write your equations, and then you finally had to solve them. Alrighty, so number 4, 2 records and 3 tapes cost $31. Do y'all even know what a tape is at this point in your lives? Hopefully. That's what I had to learn to listen to music on. 3 records and 2 tapes cost $29. Find the cost. I'm going to start underlining. Find the cost of each record and each tape. So again, with X and Y, we're talking about the cost, okay? Cost of a tape and cost of a record. Okay, so it says 2 records, so that'd be 2Y, and 3 tapes, so that'd be 3X, cost $31. 3 records, so that's 3Y, and 2 tapes, so 2X, cost $29. Find the cost of each record, okay? Well, again, if I'm thinking about the methods I could use to solve this, I could graph it, but I don't really want to, and I don't have a graph. I could eliminate, that looks pretty promising, or I could substitute. Well, there's nothing that's even remotely by itself as far as the variable is concerned. So I'm thinking elimination is the best here. Now, usually we say it has to be in standard form, but hopefully you can look at this and see that, yes, it's not in standard form, but it's really, really close, right? And we're not actually being graded right now on whether or not we have it in correct standard form. It's just put in standard form so that we can add it appropriately. But I think we can still add this pretty well. So if I go ahead and think ahead, if I start to picture myself adding this together, I'm going to get 5Y right here, and that's not going to be helpful, and 5X right here. That's not going to be helpful either. So I need to make sure that I have this prepared so that something eliminates, okay? So we need to create some coefficients that are the same. So I'm going to multiply this top equation by -3 and the bottom equation by 2, okay? My point in doing that is to create -6's here. Alrighty? Thinking ahead and I'm concerned. Oh, no, I'm not. Okay, so forget about this line. I'm not adding it. So I've got -6y minus 9x equals negative 93. In the bottom equation, I've got 6y plus 4x equals 58. Now I am ready to add because these y's are going to eliminate. Okay, so y's are gone. My x's, I'm going to be left with negative 5x. Ooh, y'all know me and these negatives. Let me just subtract it old school. I'm always afraid I'm going to mess up on these videos. So that's, oh, nope, 5 and 3. So negative 35. Okay, good. That comes out evenly. So now divide by negative 5. So x equals 7. Okay, cool. Now I'm going to go back and look at my list of my variables, right? Coming over here. X was the cost of a tape. Okay, so it's $7 for a tape. But I need to know how much it is for a record and a tape. So I still have to take that 7 and go plug it back into one of my original equations. Which is kind of annoying because these are kind of beast equations. So I'm just going to take the top one. It doesn't matter. So that is x. So really I've got 2y plus 3 times 7 now equals 31. So 2y plus 21 equals 31. Subtract 21, so 2y equals 10. So y has to be 5. Okay, so that means a tape is $7 and a record is $5. Alrighty, keep on going. Again, feel free to pause at any point and try these on your own. You have all the tools you need. All right, Timmy has 180 marbles, some plain and some colored. If the plain marbles equal 32 more than the colored marbles, how many colored marbles does he have? So again, the question is how many colored marbles? So with x and y, I've got plain number of marbles and colored number of marbles. Okay, so he has 180. So that means the plain plus the colored has to equal 180. That's a 0. My board's a little crazy there. If the plain equals, literally says the word equals, so x equals 32 more than, so 32 plus the colored marbles, so that's a y. How many colored does he have? Okay, cool, this is pretty easy. So I already have the x by itself. I'm thinking this is a perfect problem for substitution. I'm just going to take this right here and plug it straight in for x. So I've got 32 plus y, then plus the rest of it, plus y equals 180. Okay, so that's 32 plus 2y. Let's subtract 32. So 2y equals 148. Divide by 2, y equals 74. Is that what I wanted? Hey, looky there. The good thing about this question is it says how many colored does he have? Colored is the y. I just found the y. So honestly, I don't even have to find the x. I could if I wanted to, but it's not necessary because they didn't ask you for it. So I answered their question. He has 74 colored marbles. Okay. Alrighty, next one. A high school drill team held a bake sale. The number of brownies sold was 4 more than twice the number of cookies sold. The drill team sold a total of 52 brownies and cookies. How many brownies were sold? Again, so my question reveals what our variables are going to be. How many brownies? So I'm going to call x number of brownies. What's the other thing that's happening here? It's cookies, so y is the number of cookies. So I'm going to set up my equation. Number of brownies sold, so x was 4 more, so was is just like is, equals 4 more than twice the cookies. Then they sold a total of 52 brownies and cookies. So x plus y has to equal 52. Okay, this would be a great place to pause and go ahead and finish solving if you feel like you can. I'm going to use substitution because I see that the x is already by itself. I'm just going to plug it into x. So 4 plus 2y, that is the x, plus y equals 52. So then we keep going. I'm going to go a little bit quicker just so this video is not insanely long. So y equals 16. They asked me about brownies though. So I still need to figure out how many brownies there are by plugging this back in. So x plus 16 is 52. So x equals 36. So 36 brownies were sold. Continuing on, just 3 more problems. Okay, Hunter has a jar of 368 nickels and dimes. The value of the coins is $28.40. How many nickels and dimes does he have? So So X and Y, number of nickels, and number of dimes. Okay, so he has 368 total. So X plus Y has to equal 368 because it's the number of how many he has. Then they give you the value. So a nickel is worth 5 cents, and a dime is worth 10 cents. And that should all together equal 28.40. Okay, so again, I have the opportunity here to do elimination or substitution. I think I'm actually going to do elimination here because they're already set up for standard form. And all it's going to take for these to eliminate is to multiply something by something, right? I can either take that top equation and try to match it to the decimals on the bottom, or I can make those decimals on the bottom match the whole numbers on the top. And I'm actually going to do it that way, but really it doesn't matter. So I'm going to take this bottom equation, and I'm going to work on my y's. I'm going to think, okay, what does it take for 0.1 to become just 1, right? And I know that it's multiplying by 10. So really, that just means I'm going to move all these decimal points over. So this is going to be 0.5x plus y equals 284. Okay? Then I'm going to add, so I don't need this anymore, the top equation, the bottom equation. So I've got 1.5x. Oh, I forgot to do the negative. Oops. Whoops, whoops. This is when I need students in here with me telling me, wait. Okay, so I'm multiplied by a negative 10. There we go. So I've got a negative y, a negative 0.5, and a negative 284. Okay, now we're good. So I actually have 0.5x, no y, and then let's see, what is this? 8 minus 4 is 4, 84. Then I'm going to divide by 0.5, divide by 0.5. Remember, you can use calculators in here, and I get 168. Okay, so there's 168 nickels. So now to get the dimes, I'm going to plug it back in right here. And some of y'all can do that in your head. You must have 200 dimes. Okay? Alrighty, 2 more. Hang in there. I'm proud of you for watching the video this long. Hopefully you've been fast forwarding, because otherwise it's really boring. Okay, the difference between 7 times one number and 3 times a second number is 25. The sum of twice the first and 5 times the second is 95. Find the numbers. This is one of those problems that looks really impressive after you solve it, because it sounds so confusing. So this is where the labels don't really matter. X is just going to be our first number, and Y is going to be our second number. That's all it is. So the difference between, that's subtraction, 7 times one number, so 7x, and, so the difference between this and 3 times the second number, so 3y, is equals 25. The sum of, okay, so plus, the sum of twice the first, and 5 times the second, is 95. Find the numbers. Okay, so there's our equations. Now we just have to figure out what they are. Again, to me, substitution wouldn't be the best here because I'd have to work backwards and get a variable by itself, but I think elimination would be pretty good here. So I'm going to need to make some variables have the same coefficients. So 7 and 2, their least common denominator would be 14, okay? 3 and 5, their least common denominator would be 15. Really, tomato, tomato, right? But I do like that the 3 and the 5 have a negative and a positive already. So I'm going to take this top, and I'm going to multiply it by 5 to make 15. I'm going to take the bottom and multiply it by 3, okay? So instead, these are going to turn into 35x minus 15y equals 125, and 6x plus 15y equals, 285? I think that's right. Let me check. 51. Yep, okay. So now I can add. My y's are going to cancel, but then I'm left with 41x equals, 400? No, 410. That's good, because that's going to be easier to divide. So now that I have 410, move that out of the way, divide by 41, and I see that x is 10. Okay? Cool, cool. So now I just need to plug that in and get the other one. And I'm actually going to use my original equations because those numbers are smaller. So I'm going to go with like this first equation written right here in black. I'm going to go with this guy. Okay? So I've got 7x. So I just found x is 10. So 7 times 10, oops, not plus, minus 3y equals 25. That's 70 minus 3y equals 25. subtract my 70, so negative 3y equals negative 45. Divide by negative 3, and y is 15. 10 and 15. All right, I think one last problem. Okay, good. I like this one. All right, so the perimeter of the rectangle is 34. Perimeter of the triangle is 30. Find the values for m and n. I don't really need to define my variables because they don't really stand for anything. M is the height of that rectangle and the height of the triangle. It's the base of the rectangle and the base of the triangle. So I don't want to confuse myself. I'm just going to use what's written in front of me. Everything's labeled. So the perimeter of the rectangle. Well, I know the perimeter means I add all the sides. And there's 4 sides on a rectangle. So I've got m plus n, right? And all of that should equal 34. In other words, 2m plus 2n, right? Okay. Over here, perimeter of the triangle, so m plus n plus 1, that should all equal 30. So we simplify that. M plus 2n plus 1 equals 30. So now if I want to actually solve this and figure out what m and n are, I need to create a method, right? Either substitution or elimination or graphing. Graphing doesn't look good because I'd have to solve them both for y, which there is no y. I could figure it out, but I don't want to. So I'm thinking maybe standard form, okay? Because I already have mn here, and I could turn this into mn pretty easily just by subtracting the 1 over. So I've got m plus 2n equals 29, okay? So I'm going to go move this down underneath this one. Switch colors. So m plus 2n equals 29, okay? If I add these together right now, nothing's going to cancel. But I'm pretty close with this 2n business, right? So all I really need to do is multiply this bottom equation by a negative 1. That's going to create this. This is going to be a negative. And this is going to be a negative. Okay? Now when I add, I've got m equals 34 minus 29. That would be 5. There's m right off the bat, right? So now to get in, I just need to go plug it in back into my equation, right? Some of y'all can just do this mentally by thinking about that rectangle. If this is 5 and this is 5, well, that's 10 right off the bat. So it leaves me 24 to be divided between these two, so n is 12. Okay? Alrighty. This is probably one of my longer videos. Again, hopefully you were fast forwarding through this. But when you finish, there is a homework sheet that just has 5 problems you can try on your own. If you have any questions, let me know as usual.